Hello, and thank you for watching our video on registration help for chemistry, physics, and mathematics. I'm Drew Meyer, a departmental representative of the Department of Chemistry, and I'll also be teaching the Chem 105 and Chem 111 courses this coming fall.
I'm Gary Chotiner from the Department of Physics. I'm the academic representative for that department, and I also teach Physics 121 in the spring semesters.
I'm Chris Butler from the Department of Mathematics, Applied Mathematics and Statistics. I'm a senior instructor and the director of undergraduate studies, and in the fall I'll teach Math 121 and Math 122. And I want to talk a little bit about the Department of Mathematics, Applied Mathematics and Statistics. What are the different degrees does the Mathematics Department offer? Well, there are quite a few. There is the BA with major in mathematics. It's one of our most flexible degree options. We have the BA with teacher certification, so if you're interested in becoming a high school math teacher, that would be the degree for you. We have the BS in mathematics. It's a Bachelor of Science degree. It has more science courses. We have the BS in applied mathematics, so if you're interested in that. We also have the BS in mathematics and physics. And then we have 2 degrees in statistics. We have a BA with a major in statistics and a BS in statistics. So, I'm an incoming first-year student. How will I figure out my schedule? Well, there are a couple things. First, the FYR guide. It has, for each one of the different departments, sort of a outline of classes that you should take, and you should be thinking about taking 14 to 17 hours, 4 to 5 courses. So, for example, if you're doing the BS in math or applied mathematics, your schedule should look something like this. You should take a SAGES first seminar, you'll take Math 121 or another math course, you'll need to take a science course, so astronomy, chemistry, or geology, and then maybe some arts, humanities courses, and phys ed, for a total of between 14 and 17 hours. Or if you're a physics, BA or BS, or the math and physics, you should make sure that you're taking physics, either Physics 121 or Physics 123, your first semester. So, there are a lot of different calculus sequences. How do I know which one I should choose? Well, let's go through them. There are the Math 125, 126 sequence. That's for students that only need 2 semesters of calculus for their degree. So, a BA degree, biology, psychology, things like that. Then there's the Math 121, 122, 223, 224 sequence. That's for engineering students, math, physics, BS in chemistry, those students. Then we actually have an enhanced or honors sequence, Math 124, 227, 228, and we need to think about what your AP credit is. So, you took the AP exam and you got, what should you do? Well, if you got a 4 or 5 on the AB exam, you'll have 4 credits and you should start in the second semester class, depending on your major, either 122, 124, or 126. If you got a 4 or 5 on the BC exam, you'll get 8 credits and you should start in a third semester class, 223 or 227. And if you got a 5, 6, or 7 on the IB higher levels, you'll have 7 credits and you should start in a second semester class, again 122, 124, or 126. But what if you're not sure? Should you use your AP credit or not? Well, I get this question quite a bit. My advice to you is try the higher level class. If you have a 4 or 5 on the AB exam, try Math 122. If you have a 4 or 5 on the BC exam, try 223, 227. If it's not right for you, come see me and we can make an adjustment to your schedule. It's much easier to move you from the higher level class to the lower level class than to move you from the lower level class to a higher level class, because if you think about it, the students in the higher level class have moved on and you've already missed some material. If you're moving from the higher level back, basically you're going to be missing some stuff that would have been a review for you. What opportunities are there for our undergraduates? Well, there are quite a few things. We actually have some undergraduates do research with our faculty. I hire about 20 SI leaders each semester. We certainly have a study abroad program, a co-op program. We have a math club. Pi Mu Epsilon is the National Math Honor Society, and we attend many math competitions. There's an Ohio competition that we've won actually the last 8 or 9 years. I think they're getting a little fed up with us coming to it and winning every time. Actually, I think this last year we took first, second, and third for our teams. And then the next question, is there anything after calculus? Well, quite a bit. Here are some of the classes that we teach. There's knot theory, cryptology, dynamical systems, math biology. There's quite a bit to do after you finish the calculus sequence. There's a lot of mathematics there, and there are a lot of options for you. If you have more questions, because this was an awful lot of information really quickly, I actually have the easiest email address of anybody at the university. It's just chris@cwu.edu, or I have my own toll-free number, 1-800-659-MATH. And you can call me, or if you have just general questions about registration, you can send email to summerreghelp@case.edu. And there's a link to the FYR guide and to the math department homepage. Now next we'll have Drew Meyer.
Hi. So I'll be telling you a little about the chemistry department. The chemistry department at Case offers 3 majors. We have a BA in chemistry, which is our most flexible major. It really allows you to do a lot of courses outside of the chemistry track. It's a very popular major for pre-health students. We have a Bachelor of Science in Chemistry, which is a degree that's certified by the American Chemical Society. It requires it requires almost all of our undergraduate chemistry courses, and it's really designed for students who want to go on and do research at graduate school in the chemistry field. We also have a relatively newer degree that's the Bachelor of Arts in Chemical Biology. I often get the question, what's the difference between chemical biology and biochemistry? And so the easiest way, I think, to make this clear is to show this little picture. So chemistry is on one side, biology is on the other. Biochemistry originally started out right in the middle, but over the years it's migrated much more towards the biology side. It's much more about the biology of very, very large chemical species. Chemical biology is designed to kind of split this difference. It's much more about how small synthesizable molecules interact with biology. So how drugs interact with biological molecules, how we can synthesize materials to interact with biology. It's a BA in chemistry, so it's also very flexible, and a lot of the biology courses that students are interested in taking are already worked into the major, so it really gives you a lot of flexibility to take courses in other departments if you're interested. It's another very popular major among our pre-health majors in the chemistry department. I have a series of so the introductory sequence of chemistry courses. You can check the FYR guide to look at the different sequences. The chemistry department offers 2 main sequences for general chemistry. We have the Chem 105-106 sequence, which is designed for students who are going to continue on in the College of Arts and Sciences. It's a full-year chemistry course. That's 3 hours per semester, and there's 50-minute weekly sessions. This is really the best major if it gives you a really strong background in terms of general chemistry. The other course is Chem 111, which is Principles of Chemistry for Engineers. It's followed by Engineering 145, which is a chemistry materials course taught in the engineering department. The 2 courses are very similar, except for Chem 111 is a 4-credit-hour course with a once-a-week discussion section. So you work in smaller groups with students outside of the lecture period. But otherwise, the material in the 2 courses are very similar. Chem 111 has several more concepts worked into the course to make sure you're ready to move on to Engineering 145. Students often ask which course they should be taking. The best advice, I think, is if you're interested in possibly moving on to an engineering degree at some point, Chem 111 is probably the better course to take because the transition from Chem 111 into Chem 106 is very seamless. You can just enroll directly in the course. If you want to go the other way, you take Chem 105 and you want to transition into Chemistry 111. It's a little bit more difficult because there are some concepts that are worked into Chem 111. We require a proficiency exam before you can move on to engineering 145. But it is possible. So if you ever feel like you want to switch into an engineering major, it's still something you can consider, but you may want to think about starting with Chem 111 if that's something you think may be possible in the future. We have a series of frequently asked questions. So AP credits, which course sequence should I take? Should I retake Chem 105? So most of the answers to these questions can be found on the chemistry webpage. So if you go to the chemistry webpage and then the easiest way to get there is just to search for chemistry CWRU. It'll come right up. If you look on academic programs, you'll see a link to undergraduate studies. From undergraduate studies, you can click on any of the majors. There's a link on there for the information I'm going to tell you about AP credit as well. So you can explore there. And then if you click on each of the majors, it takes you to a list of which courses are required, and there's a proposed sequence on there as well, so you can look at what a sequence in one of our majors might look like. So back to the questions. Do I receive AP credits? We've recently changed what is offered for AP credits. So the way it works is that if you receive a 4 or a 5 on the AP exam or a 5, 6, or 7 on the IB exam, you'll earn credit for Chemistry 111. Now, if you're going to continue on in the School of Arts and Sciences, you don't have to worry about the fact that you're not getting credit for 105. 111 will count directly to allow you to move directly into Chem 106. If you talk to other students at Case, you may learn that many of them may have received credit for Chem 113. We've recently changed this requirement. We found that students who move directly into the upper level lab courses without having taken Chem 113 often struggle significantly. So we've made sure to require Chem 113 for any student who's going to be continuing on, so you can't AP out of Chem 113. Is there anything else I want to say about that? Yeah, that's fine. Should I retake Chem 105 if I have AP credits? The advice I give on this is that it really depends on your level of comfort with chemistry. A lot of students move directly into Chem 106 and they do very well if they've succeeded on the AP exam. A lot of students feel like they're not as comfortable and they want to retake Chem 105, and they also do very well. So it really just depends on your level of comfort. I would warn you that there's a number of students who enroll in Chem 105 assuming that it's going to be very easy, and they assume they don't need to study, and they can often struggle. So be aware that if you are going to retake 105, it's not simply showing up. You do actually have to work for that course in order to succeed. Can you take engineering 145 if you have AP credit? The answer is yes, because the AP credit gives you credit for chemistry 111. It allows you to move directly into engineering 145. Are there proficiency exams? We offer proficiency exams for Chem 105, Chem 106, and Chem 111. So the proficiency exams are offered the Saturday before classes start usually. Should you plan to take organic chemistry your first year? If you start with Chem 106, certainly you should continue to move on to organic chemistry. If you're coming in with AP credit and you feel like you're really ready to start with organic chemistry, we're more than happy to have you start there. You do need to take the Chemistry 106 proficiency exam before you can move into an organic chemistry course. If you're thinking about which organic chemistry course you may want to take, we have two different offerings. We have Chemistry 223, 224, and then Chemistry 323, 324. The first course is a relatively traditional organic chemistry course. It's taught from the sequence in terms of you learn about different functional groups, you learn about reactions that prepare those functional groups, and you learn about what reactions those functional groups can do. It's the much more popular major among pre-health students. Chem 323 is taught in a slightly different structure, where we start with the chemistry of a carbonyl carbon, the most important functional group for biological sciences, and we explore the other levels of organic chemistry through that type of chemistry. It is required for the BS and the BA to take that track, but if for some reason you decide you want to switch into BS and you've already taken the other sequence of organic chemistry courses, we can transfer that credit over to make sure that you can move into the BS track if you would like. And then these next two slides just show a couple of sequences for planning what courses you want to take in your first year. So as you can see, you should take a SAGES course, an appropriate math course. This slide is for both BA and BS. The only difference on the slides for the two majors is which math sequence you want to take. BA majors would take the 125, 126 sequence. or they can take the other sequence as well, but BS and just BS majors are required to take the 121, 122 sequence. You should then plan on taking a chemistry course, either Chem 105 or Chem 106. Chem 106 is offered both, or Chem 105 and Chem 106 are both offered in the fall semester. And then the Chemistry 113 lab, because of the changes in AP credits, we may have some issues in terms of filling the spring semester because that's the much more popular time to take the lab. So if you can fit Chem 113 into your fall semester, it is a good idea to take it so you don't have to worry about the course filling up in the spring semester. If we can fill both semesters of lab courses, we'll have plenty of room for everybody. And then you can see some other courses you should be taking, an arts and humanities course, and then possibly a PE if you have room to fit it in. For the chemical biology, you see the track is very similar. The math sequence can be either the 121 or 122, followed by the 125 and 126 sequence. Either one is acceptable for that degree. And then you can start with your chemistry and biology courses. Because the chemical biology course sequence does require biology, it is a good idea to get started with biology courses in that first year. If you have any questions about chemistry majors or the chemistry department on a whole, or which courses you should be taking, you can contact me at my email address, dam135@case.edu. Or you can go ahead and contact the Office of Undergraduate Studies. You can refer to the FYR guide, or you can go directly to our chemistry webpage, which is listed there. Okay, now I'll pass it on to Gary for physics.
So I'm going to talk about physics at Case Western Reserve University. Let me first start off by talking about physics for students in general, not necessarily physics majors. And we offer 3 introductory physics sequences for students at CWRU. They go by the numbers Physics 115, 116, that's one sequence, then 121, 122, and finally 123, 124. The physics department doesn't tell you which sequence you should take. That's actually your intended major. The department in which you plan to major, you might major, that will determine which sequence you should take, unless of course you want to major in physics. In that case, we would tell you which sequence to take. So if you want to know which of these sequences applies to you, you really should refer to the FYR guide and look at all the majors that you might potentially take to see which sequence you should start with. But I can make some general statements about them. Physics 115, 116 may include a little bit of calculus, but they're basically algebra-based sequences. They're designed to appeal to life science majors. And so if you're going to pursue a BA in life science, this is probably the sequence that you'll take, but you probably won't want to start it in your first year. That's unusual. Most students in these majors will start off in math, etc., and then take Physics 115, 116 in their sophomore or junior years. Physics 121, 122 are what you might call our standard calculus-based sequences. And so those are required by most engineering degrees, almost everything except the BA in computer science, and also for BS science programs outside the physics, etc. So for example, for the life sciences, you are likely to be required to take Physics 121, 122. But again, for those majors, probably not in your first year. But if you're considering major in physics and astronomy or in any engineering discipline, it's likely that you'll start this sequence, Physics 121, 122, in either the fall or spring of your first year. And again, the FYR guide will tell you whether you should try to start it in the fall or wait until the spring. We also have what we call an enhanced version of Physics 121, 122, which has the numbers 123, 124. You can only enroll in this course if you receive an invitation. Those will be sent out this summer. We only have Physics 123, 124 in the fall and then the spring semester. If you're undecided about a major and are confused about which physics sequence you should take, you should realize that Physics 121, 122 will work for almost every major at CWRU. So that's the safe bet, especially if you're considering a combination of majors that might have different requirements. 121, 122 will be accepted by every department on campus. In terms of when these courses are available, we only offer Physics 115 in the fall semester and Physics 116 in the spring semester, although also in the summer. And so you can't wait and start Physics 115 in the spring, for example. But you probably won't be taking it your first year at all, so that's nothing to worry about. Again, with Physics 123, our enhanced version of classical mechanics, we only offer that in the fall, and the second course in the sequence, Electricity and Magnetism, is only offered in the spring. We do offer Physics 122 and 121 and 122 both semesters, fall and spring, so you can start the sequence either semester and finish it either semester. And we also offer that in the summer if you need to take it then. And again, the FYR guide will tell you when you should take either of these courses. Okay. One thing I want to tell you is when you go to register, you may see that the labs you want, or perhaps all the labs in Physics 115, 121, and 122 seem to be full. We will accommodate all students who need these courses. Our dean has instructed us to do just that, so that if these courses fill up, we will add sections. So don't panic if that's what you run into. We'll make sure you get into the physics courses you need. Now, Physics 121, I said was our calculus-based sequence. You need to know calculus from the day you walk into that course. It requires understanding of basic differential and integral calculus. Now, the student information system doesn't list that as a required prerequisite because we allow students who have a year of high school calculus to start in that course. But if you don't have a year of high school calculus, don't enroll in Physics 121. It won't work. The first week of class, I'll be talking about integrals and derivatives applied to introductory physics. Physics 123 is designed for students who have an interest in physics, but not necessarily as a major, just a deep interest in physics for its own sake, not because it's required for some other major you might pursue. If you do receive an invitation and you're unsure about whether it's right for you, we have a posting for that. You can see the link to it in this slide. So if you have any concerns about whether you should accept an invitation to Physics 123, read this link, and if you still have questions, contact me and/or the course instructor. Okay. Physics 166 is another course I want to talk about. It's called Physics Today and Tomorrow. This was actually created at the request of our students, because when you take introductory physics, you see people like me sliding blocks on inclined planes, but that's not what physicists do for a living. So our students said, we'd like you to create a course accessible to freshmen, to first-year students, that shows us what you might be doing if you majored in physics and had a career in physics. So we created a course where every week someone comes in and talks about what they actually do with their physics degree, with their physics background. So you see things in here like MRI machine. We have one of the world's leaders in MRI, magnetic resonance imaging, and Professor Brown. We have people who do work in the art world and use their physics in that, or quantum computing, and a whole list of things. I won't go down the entire list. But this is a one-credit pass, no-pass course. And so there are no exams or homework, for example. You just have to show up for the classes. And this will give you an idea of what physicists actually do. And so you might decide that this is something you might like to do. That's the reason for it. Now, if you have questions about things like AP credit, physics degree programs, etc., I'd encourage you to look at the link I give you on this page, although I have to warn you that the university is going to change our URL at some point. Right now, everything is on a server that's in the physics department, and they want to move it to a server that the college controls. That will change, but links will be forwarded, so it shouldn't be a problem for you. But this page, which I'll show you in a minute or two, the undergrad page on our website, gives you details about our introductory physics sequences beyond what I've just told you: AP credit, transfer credit, proficiency exams, detailed descriptions of our physics degree programs, typical, not just first semester schedules, but 4-year schedules for all of our majors, and talks about the ways that you can get involved in undergraduate research, co-op, study abroad, etc. Okay? So let me give just a little bit of advice for first-year students who are considering a major in physics or engineering physics, which is actually in the School of Engineering, but is a physics degree, and it's based in our department. Okay? First of all, don't worry too much about which degree program you'll pursue. There are 7 of them listed on our website, and I'll show those to you in a moment. But you don't have to agonize your first semester over which one is best for you. The things you need to be concerned about are just a few distinctions between them. You've already heard about the issue of Chem 105 and Chem 111. The School of Engineering wants students to take Chem 111. So if you're at all tempted to pursue a degree in engineering, go ahead and start in Chem 111. Okay? If you're not, I think we'd recommend Chem 105, 106 for most physics majors otherwise. The other thing I should warn you about is that if you're interested in a major in computer science, we recommend that students in their first or second semester do Engineering 131, but the computer science department prefers their students to do a Java-based rather than MATLAB-based course, and so you should sign up for EECS 132 instead of Engineering 131. There are actually 2 more pages of advice like this on the link you can see underneath the title, advice.pdf, which goes into all the gory details about things you might be interested in learning if you're interested in majoring in physics. Okay? As far as what you will do your first semester in the fall, it's usually pretty easy. You'll sign up for the math course recommended by the math department. They'll place you in the first, second, third, fourth, or enhanced versions of the math courses. You'll likely sign up for a physics course, assuming that you've had calculus in high school. You'll take the appropriate chemistry course and the SAGES first seminar. And signing up for these will prepare you for a wide variety of majors. Any of our physics majors will be satisfied with these courses in the first semester, and almost any engineering major would be satisfied by the appropriate selection, doing Chem 111 instead. So you don't have to agonize over which versions of these you take. If you're invited to enroll in Physics 123, consider it carefully. It's not the right choice to accept that invitation to everyone. You might be better off skipping mechanics altogether and starting in the second semester. So it's a very personal thing, but consider it very carefully. 123 is not just a rehash of 121. It's enhanced, and that means it includes a lot of special features, like topics you would not see in a high school AP course, chaos, for example. So it's meant to be more interesting and to teach you to think like a physicist instead of just problem-solving skills that are needed by engineers and others who take physics. Also consider, if you can fit it into your schedule, Physics 166, Physics Today and Tomorrow. It's 1 credit, but requires very little additional work. So if you have room for an additional credit, consider taking that. If you want help, okay, you might start off by looking at the FYR guide. It's a wealth of information in there. But if you have questions about physics, please send me an email. That's the best way to contact me, and I'll get back to you within a day or so, typically. If you have questions beyond physics, Dean Mason might be the best person to talk to. And also look at the postings I've just described to you, and I'll lead you through those in a moment. And again, that URL is going to change to the one you see below, physics.case.edu instead of phys.edu. Okay? So here is our homepage as it looks now, a homepage for the physics department. And the red arrow shows you an area called academic programs, and another arrow next to it shows you undergraduate. And those are the web pages that I maintain. So all the information you see on this page, I've put there. It starts with degree programs, goes on to course descriptions, and then you see highlighted introductory physics. So if you were to click on that link, you'd get to another page that would give you more links to AP credit, transfer credit, and proficiency exams. So for example, if you have AP credit for the Physics 1-2 algebra-based physics, that would get you out of Physics 115, or algebra-based sequence. But be careful. The engineering school does not accept Physics 115. So if you want to be an engineer, that won't be terribly useful to you. You need Physics 121 credit, and it's the School of Engineering that insists on that. If you have AP credit for the calculus-based exam, you'll get credit for Physics 121, and you can move directly into Physics 122 if you wish, or put it off for a semester, or if you receive an invitation to Physics 123, you might decide to do that instead. But again, all the details are on that link that you see there. And if you don't have AP credit for something, like we do not give credit for our second course in the sequence, electricity and magnetism, because we found historically that doesn't work for a lot of students. But you can always demonstrate that you should receive that credit through a proficiency exam, which all 3 of our departments provide. It's like taking a final exam. That link actually will take you to sample exams, so you can see exactly what it's like. And the schedule will be set by the Office of Undergraduate Studies. These exams typically occur a few days before classes start in the fall semester. So this next link that I highlight here would take you to detailed descriptions of our degree programs. So if you were to follow another of the links on that previous page, that would take you to descriptions of our degree programs, or links to descriptions of our degree programs. And there are 7 of them listed here. The first posting that you see with the arrow is actually the advice for physics major, or advice for majors posting that I've got there. It's about 12 pages of things that advisors will tell students, or might forget to tell students, or students forget they've been told. But the first 2 pages are designed for first-year students, all the things you might want to know if you're considering becoming a physics major. The links below that lead to detailed descriptions of our degree programs, including the purpose of each degree programs, like is it designed to train you to go into a PhD program in physics, Or is it designed to give you lots of flexibility so you can pursue multiple degrees, or engineering physics, or one that Professor Butler described earlier, math and physics, which is actually a degree program supervised jointly by both departments for students who are interested in both mathematics for its own sake and physics for its own sake. So you can click on any of those links and learn more about them, all the required courses, and a typical schedule over 4 years for students who pursue those degrees. But again, don't worry too much about this as an entering first-year student. If you take the reasonable courses that I described at the beginning, you're prepared for all of them. In fact, you often don't have to decide between them until your sophomore year. Okay. One last thing I want to mention, leaving physics now for a moment, is there's a new major available on campus. It's called the Origin Sciences major. It involves several departments across campus and actually institutions not in Case Western Reserve University, like the Museum of Natural History. It was actually started by a physicist here, but it cuts across the university. You see a link there to the website. The details of what you should register for aren't yet quite available, but they will be posted soon. And so if you're interested in this major, which lets you, for example, for a pre-med student, talk about biology and paleoanthropology, or if you're interested in physics, for example, you might emphasize cosmology and astrobiology. You'll be able to find out more details about this later this summer.
I think I speak for all three of us as we look forward to meeting you this fall, and best of luck over the summer.
And thank you very much for watching our registration video.
And if you have any additional questions, feel free to contact any of us about either math, chemistry, or physics. We'll be accessible all summer long and be glad to answer any additional questions you might have.